Hi students, this video is on plate boundary types. One of the things that you'll learn in this video is that you will understand the three main types of plate boundaries, then be able to predict which of these plate boundaries will have volcanoes, mountains, island arcs, and any other types of geological features, and then understand why earthquakes occur at these different boundaries. So to get started, this is a poorly built fence, and actually it's not. It's a well-built fence, just built on a fault line. The San Andreas Fault runs right through this fence, and after the 1906 earthquake, it shifted the land. This part of the fence went this way, and this part of the fence went this way, and this is what's called a transform fault. So we'll take a look at one of those in a little bit here when we go over the different fault types, but what you're seeing here is visual evidence of when a structure is built right across a fault line. And there's several events, places on planet Earth where you can see things like this. In fact, the San Andreas Fault runs through a lot of San Francisco, but especially up through Point Reyes. And as Point Reyes moves, I believe, this direction down, the Pacific Plate is moving up this direction. Or I'm sorry, the North American Plate is moving up this direction. And so as that's happening, there's a lot of earthquake activity that can occur, and that fence will continue to get further and further apart, because that's where that picture was taken. Okay, so here are the three different types of boundaries: divergent, convergent, and transform. So a divergent boundary is when they go apart from each other, they diverge. Convergent boundary is when they meet together, converge, and transform is when they don't really do either of those things, but they slide past one another, and activity happens in between that space where the two plates slide past one another, kind of drag across one another. The first type is called a divergent boundary, and it's most notable for what's called the Mid-Atlantic Ridge. This ridge is basically two plates, in this case the North American Plate and the Eurasian Plate, going two different directions. And along this is basically the world's largest chain of mountains. And this is a kind of a cool thing that people get to do, which you're seeing the diver do in this photo. If you go to Iceland, you can dive between the two plates. And he's right now put his feet on the North American Plate, a North American Plate, and he's put his head on the Eurasian Plate. So he's essentially put his body on two different parts of the planet at once, which is kind of neat. So you can swim through there, and there's pictures of people swimming through there and touching both sides. Okay, so some details about divergent plates. First, there are two plates that move away from each other, and that happens due to magma rising up between the plates. So down here, there's the formation of magma that's heating up because of the core of the Earth. And so you have magma rising up and putting pressure on these two plates and pushing them apart. It can happen in the ocean, of course, oceanic crusts. In the case of the Eurasian Plate and the North American Plate, it's two oceanic crusts. Remember, there are two crust types, oceanic and continental, but it can also occur in the middle of a continental crust as well, between two continental crusts. We'll see an image of that as well. And then those convection currents end up pulling the lithosphere, or what we might just call the crust, apart. So as those convection currents kind of drag along here, they're pulling the crust along with it. If it happens in the middle of a continental crust, it will eventually split that crust kind of in half, and you will have the birth of new oceanic crust. But that will take some time. and first begins as a rift valley, and then you get sort of the filling in of some seawater. All the while you're getting more and more magma rising up between here, and that will of course cause some volcanic activity as well. The next type of boundary is called a transform boundary, and that's the one that we looked at the beginning, the San Andreas Fault. This is a picture of it from the air. You can see pretty good visual evidence of the fault in certain parts of the state, in addition to that fence example I showed you. But some key features about transform faults. First, it's two plates that are moving away from each other, but not moving at each other. They're just sliding past one another, and when this happens, they drag and cause earthquakes. So the earthquakes are caused because the rocks are essentially breaking apart. They stick together, and then they kind of build up all this pressure as they get stuck together, and then when that pressure becomes too great, it finally breaks the friction hold and it releases, and it moves quite a bit all at once. And when that happens, you get a very violent earthquake. So this can happen gradually, or it can happen in a very brief moment. And those very, very brief moments, the ones where we get a giant earthquake, are the most destructive in California especially. The next plate boundary is called convergent, and this is the last one here, but in convergence you get you basically have two plates who run into each other, and when they run into each other, one of two things will happen. Either they'll kind of smash into each other, or one will duck under the other, depending on their density. In this case, the ocean crust is going to dive underneath the continental crust, and an example of this happening is in Oregon. These are some of the Cascade Mountains, Cascades. And in Oregon, Washington, even Mount Shasta in Northern California is a part of the Cascade Mountains. And what you have is the ocean diving underneath the continental crust, and when that happens, it starts to melt pieces of the continental crust down in the magma, and when that happens, that magma starts to rise up and become a volcano. So this is when volcanic activity, let's try that again. These are when volcanoes occur. So all of these would be volcanoes. Whether or not they're active or dormant depends, but the last time one of them erupted was in 1991 when Mount St. Helens blew its top and was a massive destructive event. Just to detail a couple things that you can write down, the two plates moving towards each other, we call that convergent, and the denser crust always goes underneath. So that'll always be oceanic crust if it's there. So ocean to ocean crust. But you can have oceanic and continental crust meeting, and you can have continental and continental crusts meeting. So what is the difference between those? Well, whenever we have an oceanic crust diving underneath a continental crust, as we said, like with the Mount St. Helens and Cascades example, you're going to get volcanoes. But that's not always the case. If you have continental crust occurring, then you'll actually have a mountain range where the two sort of smash together, and you get a range of mountains, but they're typically non-volcanic because this continental crust doesn't ever really melt to the degree as when the oceanic crust melts. There's some different components in oceanic crust that when they melt tend to turn into magma in particular that can go out of a volcano. Another time you could get volcanoes is actually when two oceanic crusts meet, and when that happens, one does usually get sucked under the other. It has to go somewhere, and so when that happens, whichever one tends to be more dense will inevitably make a volcano, and usually you'll have what's called an island arc, multiple islands formed right at the meeting of those two types of crust. A good example of this would be probably like New Zealand or around in the Philippines. Okay, So the final statement here is just to remind you that where do earthquakes occur? Pretty much all plate boundaries are where earthquakes can occur. And that is the different types of plate boundaries. Hope that was helpful.